outside of Thailand. After the break, we actually want to be able to show you imagery that we've collected very recently from Thailand and some of the applications. So I think you'll find this quite interesting because this is imagery that's been collected actively over your own country and reveals some very interesting information. But we're happy to answer any questions. Otherwise, we'll be able to continue after the break. Yes? Say that again, I'm sorry. Yeah, no, that's a very good question. So after the break, Alex will be able to take you through how we make the data available. But to answer your question in a general sense, from the time the data is collected and downlinked, it typically only takes us a couple hours we have an automated system that will process the image, will rectify the image, basically turn it into a geospatial piece of information that I can put into a geographic information system or work in a map with. So it's only a matter of hours. As an example, we captured a number of images of Thailand just yesterday in the afternoon, and they're already available today in my web browser. I'll be able to show you those. So it's a very rapid process.
Mm-hmm. There was another question in the front row.
Hi, good morning. Thank you very much for the excellent presentation. I'm going to ask you a generalist question. Number one, are these PowerPoint accessible to any of us after the presentation? Mm-hmm. That's one. The second one would be, you show us the satellite. The size is very tiny. And you also compared it to the largest one at the initial stage. Does this mean in 2 years' time, we will see even a smaller one than this? And a link to that, you mentioned about experience at the customs, bringing this small satellite into Thailand. Yeah. I want to project it a bit further, because you were talking about launching 28 satellites, just like that, easy, to launch that. Question is, do you face some experience, some difficulty in terms of launching protocol? Because obviously your satellite will have to orbit the Earth. That means that it orbits countries around the world. And therefore, what are the difficulties that you may have faced? Could you kindly share that with us? The maybe final one at this stage is that you talk, of course, about the imaging the planet itself. Obviously, that is the surface. Nevertheless, the causes of disaster is not only on the surface. Mm-hmm. It comes also from under the earth, under the ground. Question to you is that in terms of your roadmap, do you foresee going a bit further in your expedition, in the technology, to look into element under the earth that can trigger disaster or even social disorder in this respect? Thank you.
I'll answer the first two questions, and I'll let Alex answer the last, more difficult question. So regarding the information that we've shown you today, I believe that our partners MapPoint Asia will be making this available to all attendees. So you'll basically have a PDF version of everything that we've shown today. And also, we've gathered a number of images, sample images from Thailand, given them to our partners at MapPoint Asia. You'll be able to download those. And these are orthorectified images that you can use in your GIS software or your own mapping environment. The other question was regarding how we launch and what sort of issues we may have. The interesting thing about the law of space is that it is pretty simple, because traditionally not many people have been launching things into space. Of course, more recently, lots of things are going into space. We are regulated. We're a U.S. company. We're regulated by the U.S. federal government. Every time we launch to space, we have to get authorization, of course, from NASA and some other departments, regulatory aerospace departments in the U.S. Basically, we have to show that we are not contributing to space debris, which can be a problem. And I imagine when you think about the numbers of satellites we're launching, if those satellites stop working, that conceivably could be a lot of debris. Actually, our satellites in the lower orbit, when those quit working or we want to replace them with new satellites, we actually decommission them. Given the size of the satellite, when they go back into the atmosphere, they burn up. They don't cause any issues. And regarding our spatial resolution in terms of privacy, our founding team actually selected our spatial resolution of 3 meters as a way to avoid privacy concerns. We're more interested in monitoring environmental phenomenon like deforestation or flooding versus getting into privacy concerns. So with our data, you can see a lot of things, but very sensitive and specific things, probably not because of our resolution of 3 meters.
Mm-hmm. Now, just to follow up on Bo's comments, before we put any satellites into space, we have to run a tremendous amount of analysis and calculations to make sure that the probability of anything going wrong is so infinitesimally small that it is basically not going to happen. I think we were just recognized as responsible users of space by some of the regulating bodies. So we pride ourselves on being not only at the forefront of technological innovation, but at the forefront of using basically global resources, common global resources, in a safe and responsible manner. And we hope that those that follow us will do the same. Regarding future technology demonstrations, we are able to do technology demonstrations very quickly because we design and build quickly. Will we change the form factor of the satellite? Potentially, yeah. Our focus right now is on this form factor and what we can achieve, and it's called a 3U or 3-unit form factor in the space industry. We could go smaller, we could go bigger, and with those different directions come different opportunities. You can replace the sensor payload with different types of sensors, which would give you different information, be that spectral or other types of information. So we do plan on a number of technology demonstrations. If anything, the satellite might get a little bit bigger rather than a little bit smaller, but we'll have to wait and see what the technology team comes up with. I think I'm still missing one. Oh, yeah, subterranean imaging. That's not quite on our roadmap at this point in time. That would require some very specific and significant sensors within the satellite, but we are absolutely interested in hearing about your requirements because that might give us ideas for future directions to move in. Did I miss anything? There were a lot of questions packed into that. Oh, distribution, yeah. So as Bo mentioned, I believe you have thumb drives that have our presentations on them. They should have examples of the images. If not, we can make sure you get them. And we're actually going to talk a little bit about how to access our imagery kind of more broadly. One of the biggest problems with satellite imagery is it's just hard to get. Like, where would you find it? You find it in Google Maps, but that's because Google Maps has gone and purchased it and dumped it onto their internet environment. That isn't getting access to the kind of raw underlying imagery. And one of the key tenets Planet Labs was built on was actually access. And we want to create access in a couple of ways. And I think we have a few minutes before the coffee break, so I might just jump into talking about that. So making imagery accessible. Fortunately, this was queued up on the slides. So this is a little bit small, but what this describes are kind of all the parameters by which our imagery will be searchable and sliceable and diceable. So when you come to our interface, and this interface is something we call an application programming interface. So this is for the power user or the very advanced technical user. That user may want to come and ask a very specific question, like, did you take a picture with satellite X at location Y at time Z with camera settings X? And so we allow the user to search by a number of parameters. And I'm not going to go into it, but pretty much anything you would need to find the specific image you are looking for, we include in a very robust set of metadata that comes with our imagery. Now, this API is designed to deliver imagery at scale. As we mentioned, if we're capturing 150 million square kilometers every day, that's a ton of imagery. That isn't an amount of imagery that a human can easily handle. So this would allow you to plug directly into our storage system and then pull at speed huge volumes of imagery. Now that is useful just because in this new world, you won't be looking at 1 or 2 images, you'll be looking at thousands or 10,000s or even millions. So you need to